Hello class, and welcome to today's algebra lesson, which is about solving quadratics by graphing. By the end of today's lesson, you will be able to find solutions for our quadratic functions by using graphs. So when we are looking at solutions to quadratic functions, we are looking for where they cross the x-axis. So we are looking for those x-intercepts. That's going to tell us what values of x can be plugged in to solve the equation. There are three different scenarios for our answers. The first one is that there are two real solutions. So your U shape, whether it's going down like this one, or if it turned and went up, opened upward, it crosses the x-axis at two distinct separate points. Another option is for it to just hit once. This one shows it opening up. It could also be the same opening down. It just hits at one particular point. And then we have our solutions where there's actually no real solution. Your quadratic never actually touches the x-axis, whether it's going up or down, to the left or to the right, it never actually crosses over the x-axis. So we're going to go over these using our principles that we learned from graphing in our last lesson. The first thing we need to do is find our axis of symmetry. So I'm going to start by labeling my A, which is -1, my B, which is -3, and then my C, which is 18. I need to find my axis of symmetry, so I'm going to have X is equal to the opposite of my B value, so +3, over 2 times my A value. So I find that my axis of symmetry is 3 divided by -2, which is the same as -1.5. So I come over -1.5 and I put in that vertical dashed line that's going to help us figure out where our points are reflected over. Then I need to figure out my vertex. Remember, in order to do that, you are taking your answer for x and plugging it in. So I've got negative, and then in parentheses, -1.5. The -1.5 is my x. This outside negative is the negative in front of my x squared. So I've got -1.5 squared minus 3 times -1.5, and then adding 18 to that. When I do that, I'm going to get a point of -1.5 and +20.25. Now that's not going to fit on my graph. Since it's 20.25, that's barely above 20, so I can go ahead and just count by twos. So I'm going 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Remember, if I'm counting up by twos, that means I'm also counting down by twos. You just don't have to fill in the down part. So at 20.25, I'm just barely above my graph. So that is our vertex. Now I need to plug in some numbers, remembering that we are going down. So I'm going to plug in some values and hopefully get some points below my vertex. After 1.5, I'm going to go ahead, or excuse me, -1.5. I could plug in -1. I'm going to go ahead and plug in 0 into this scenario just to give me a little bit more space to work with. So I would go negative and then in parentheses 0 squared minus 3 times 0 plus 18. And that is going to give me a point of 0.18. So I go over 0 and up to 18. Remember, we're counting by twos. And then that's 1.5 spaces to the right. So I'm going to go 1.5 spaces to the left for that reflection point. So I've got my first pair. I could go ahead and plug in 1. I'm going to give myself, once again, a little bit more space to work with. I'm going to go ahead and plug in 2 into the problem. So I've got negative, and then in parentheses, 2 squared minus 3 times 2 plus 18. And when I do that, I'm going to get a point of 2, 8. So I go 2 to the right and 2, 4, 6, 8 up. When I look at that, I need now to do my reflection. So 1, 2, 3.5 spaces back, 1, 2, 3.5 spaces beyond that. Then I'm going to go ahead and connect my graph with that curved shape. So, oopsies. Again, a little bit difficult with this tablet. So I'm going to go ahead and do my curve and try one more time to get this correct. There we go. Now we're going through all of our points. And as we go, we're going down on both sides. Try that again. Down on both sides of our graph. We want to make sure that we're maintaining that U curved shape. So now our last piece that we need to figure out is what our actual answers are. As you'll notice, it's not going to be perfect, but we are going to go for the closest point. So as you look, it's clearly beyond the 2 because we already know the answer for 2. So my closest point over here and my closest point over here. When we plug in our answers, or when you're solving these, we always want to list the smaller value first. So in this case, our first answer would be x is equal to -6. And our second answer is going to be that x is equal to 3. So those are the two solutions to my quadratic function because that is where it crosses the x-axis. Go ahead and try this one on your own. Starting by finding that axis of symmetry, again, we have our A value was 1, our B value was -2, and our C value was -8. So I've got the opposite of B divided by 2A. 2 divided by 2 gives you 1, and we've got that dashed line up and down our graph. Then we plug in 1 and we find that our vertex is 1, -9. So we've got that intersecting point on the axis of symmetry. Positive number in front since it's just a 1 here, so we know that our graph is going to be opening up. We could have plugged in 2 into our problem since we are just moving 1 space over. If you had plugged 2 into your equation for your second point, you would have gotten an answer of -8. So you could have put this point right here and done your mirror point then across over here. Then we can go 3, which is -5. Again, I have those points there. When you plug in, if you had gotten to 4, you would find that 4 gives you 0. As would -2. So those are your two answers. I went ahead and plugged in 5, and those are the last 2 pairs of points that you could have gotten for your symmetry. Your answers for this problem should be -2 and +4. For this next one, you will notice that we only have 2 pieces of our quadratic function. So I'm going to go ahead and fill in what is missing. I've got x squared plus 0 regular x's minus 36 is equal to 0. So my A value is 1, my B value is 0. That didn't exist in our original equation. And our C value is -36. So to find our axis of symmetry, we're going to go the opposite of B. The opposite of 0 is just 0. Over 2 times our A value, which in this case is 1. 0 divided by 2 gives us an axis of symmetry at x is equal to 0. So our y-axis is actually our axis of symmetry this time. So we put in our dashed line right at x is equal to 0. Then we need to go ahead and plug in for our vertex. We plug straight into that original equation. So I'm going to plug in 0 squared minus 36, and that gives us our vertex point at 0 and -36. Once again, that is not going to fit onto my graph, so I'm going to have to go ahead and relabel my axis. So I've got, Again, we're going down this time, so I'm going to go down. I'm going to count by 4s, so -4, -8, -12, -16, -20, -24, -28, -32, -36, and -40. So I'm going to go ahead and put that vertex point on there now, which is at 0, -36. So down here at the bottom, I've got a positive x squared, so all of my points should be coming up from there. I could plug in 1. I'm going to give myself a little bit more space, and I'm going to plug in 2. So I'm going to go 2 squared minus 36 is equal to -32. So I've got a point at 2, -32. So over 1, 2, and I'm at -32. So that reflection point then is going to be 2 spaces to the left. Then I can go ahead and plug in another number. I'm going to skip over 3 and go to 4. So when I plug in 4, I'm going to have 4 squared minus 36. That's going to give me a -20. So I've got the point 4, -20. So I'm going to go over 1, 2, 3, 4, and down 4, 8, 12, 16, 20. That is 4 spaces to the right of our axis of symmetry. So our symmetrical point is going to be 1, 2, 3, 4 spaces to the left. So now we need to go ahead and connect our curve. We want to make sure this is as smooth as possible. So I'm going to go ahead and connect here and draw that continuing to go up, and connecting my other side, drawing that to continue to go up. I am now looking for where my graph crosses that x-axis. In this case, I've got 1, 2, 3, 4, 5, and about 6, and 1, 2, 3, 4, 5, and about 6. So my 2 answers would be x equals -6, remember listing that smaller one first, and x equals +6 on the right side. Go ahead and try this one on your own. Once again, our first job being to find that axis of symmetry, you would have had to fill in and said x squared plus 0x minus 49 is equal to 0, giving you an a of 1, a b of 0, and a c of -49. So we find out our axis of symmetry, once again, is that x equals 0, and your vertex is at 0, -49. Counting by 7s, I counted up instead of counting down, but we are still counting by 7s. Then we need to be plugging in those points. Again, I went 2 spaces over to give me 2, -45 to start. You could have plugged in 3, 4, 5, 6, 7. I went all the way up to 8 and got 315. We are now looking for where it crosses our x-axis, and that is going to be at -7 and at +7. Sometimes our equation or our function is not going to be entirely put together right now. So I've got x squared equals -8x plus 16. In order to be able to graph, in order to be able to solve these, everything needs to be on one side of the equation. So I'm going to add 8x and add 16. We always want to try and keep that x squared positive whenever possible. So we can't actually combine any of them because there are no like terms. So I'm at x squared plus 8x plus 16 is equal to 0. Now I can go ahead and continue with my graphing process. A is equal to 1, B is equal to 8, C equaling 16. So for my axis of symmetry, I've got the opposite of B, so -8 over 2 times 1, giving me -8 divided by 2, meaning that our axis of symmetry is at x equals -4. So 1, 2, 3, 4 to the left, and we're going to go ahead and put in our dashed vertical line there as our reflection point reference. Then I need to plug that -4 back into my function. I'm going to use this rearranged function right here, not my original, so that I don't have to solve further. So I'm going to take, and I have -4 squared plus 8 times -4 plus 16. When you plug that into your calculator, you are going to get an answer of 0. So your vertex point is at -4, 0. Once again, that is on that axis of symmetry. So now I need to start plugging in other points into my problem. To the right of -4, I have -3. So when I plug that in, I'm going to have -3 squared plus 8 times -3 plus 16. And that is going to give me an answer of +1. So my point is at -3, +1. So I go over -3 and up 1. That point is 1 to the left, so I'm going to do a reflection point at 1 to the right. I can then keep going and plug -4 into the equation. Or excuse me, not -4. We are moving to the right, so I'm going to go ahead and plug in -2. So I'm at -2 squared plus 8 times -2 plus 16. And that answer is going to give me 4. So my next point is at -2, +4. So -2, 1, 2, 3, and 4. Reflection point then is 2 spaces to the left of my line, putting it over here. And then we go ahead and connect that U shape on our graph and drawing it a little bit more accurately, going up through those points. And we are looking for where it crosses the x-axis. In this case, it only crosses at one point. So your only answer here is going to be x is equal to -4. That is the only space where it crosses the x-axis. Go ahead and try this one on your own. In this case, the best thing to do is add 2x, not 2x, x squared to both sides of your equation. So our a is now 1, our b is -10, and our c is 25. We end up then with our axis of symmetry at +5, our vertex at 5, 0. Plugging in our extra points, I plugged in 6 and 8. If you had plugged 7 into your equation, you would have found out that 7 had points at 4, so the reflection point for that would have been 2 spaces over at 4 as well. As you finish this graph, you find that your answer to the equation is at x equals 5. It only touches at a singular point. Last example here, we've got x squared plus 2x plus 3. So our a value is 1, our b value is 2, and our c value is 3. Axis of symmetry, we're going to take the opposite of b, so -2 over 2 times 1. -2 divided by +2 gives you an axis of symmetry at x is equal to -1. So we go 1 to the left on our graph, and we plug in that dotted reflection line that we will be using to complete our graph in just a moment. We now take that -1 and we plug it back into the equation to find our vertex. So I've got -1 squared plus 2 times -1 plus 3. And when I do that, I get an answer of 2. So my vertex is at -1, +2. So 1 to the left and 2 up. Then I need to continue to plug in points. So after I plug in -1, I'm going to move 1 space over and I'm going to go to 0. So I've got 0 squared plus 2 times 0 plus 3, which is going to give me an answer of 3, meaning my next coordinate is at 0, 3. That's 1 to the right, so our reflection point is going to be across that dashed line at 1 to the left. So now we need to get another point. I'm going to go ahead and plug in 1. So I've got 1 squared plus 2 times 1 plus 3. 1 squared is 1. 2 times 1 is 2. Plus 3 is going to give me an answer of, or a final total of 6. So I've got 1 and 6. So I go over 1 and then up 1, 2, 3, 4, 5, 6. And then that reflection point going 2 spaces over the other direction on my line. So my reflection point ends up right here. I'm going to go ahead and connect my dots now to get that U parabola shape. And as you can see, this U parabola never actually, and that shouldn't go straight up, so we curve it out. There we go. Our parabola never actually touches our x-axis, so this is an example of no solution. There are no x-intercepts. There are no solutions to this quadratic. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.